Hello, everyone. I am Edward Porter. I'm going to sit down because I have to use my keyboard at some point. Just makes it easier. So I know I'm standing in the way of lunch. Good news, this may be introductory for some of you, but for others, maybe it'll be interesting and spark your appetite. I don't know. So brief introduction as to who I am. I'm Edward Porter. I'm the tech lead for documentation publishing in our doc delivery DevOps engineering group. That's a rather new grouping, and I think it informs my approach in this project. Since going into the DevOps group, we've changed a lot of our tooling to be more microservices oriented and containerized. Like a lot of our microservices now are an internal instance of Kubernetes. And so you may be familiar with using Kubernetes or using Docker for that, but in this talk, I'm going to talk about containerizing our actual build tooling so we can kind of make it easier to share with people. This is useful for us at SAS because we're an analytics company. We have our own programming language. We have very smart people who don't trust tech writers to document their own documentation. We have people who've patented algorithms and whatnot, and so they'll actually document their own corners of the SAS programming language, or in this case, document directly in their source code, and we're trying to facilitate that. So, quick overview, I'll give you some conceptual landmarks in Docker if you're not familiar with containerization and whatnot, and then I'll talk about my use case, and I'll demo it, and some brief considerations if you pursue this path, and talk about some next steps. So Docker is, if you're not familiar, a software platform for virtualizing OS and isolating applications. Generally speaking, that's used in microservices. You package up your software, your microservice, and then you can deploy it basically anywhere very easily, isolated from any other applications on that system, unless you tell it otherwise. Those containers are created by images, which is like a recipe for that OS, and anything stacked on top of it. These images can be based on one another, and I'll show how that's relevant in this situation, and some possible next steps. So this is a brief generalization or visualization I stole from Docker's website. This is the daemon, which is what you would interact with if you're running it on your computer or running it somewhere else. And I'll show you running at the command line these specific commands to either like build an image or just run one or pull one from a relevant registry. So isn't Docker just for microservices? Or why would you containerize your tooling? So generally speaking, yeah, it's for microservices. It's very easy to run long-standing processes if you've containerized it. It makes it easier to build redundancy. You can have multiple containers running at the same time. If one falls down, you have a load balancer in front of it, and that one will be replaced if you're using like Kubernetes. In any case, you can also do this for once run situations, for temporary instances. So I've created an image that you just run like you would run a normal command line application. So you just run Docker run blah, 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 pass in your parameters, and it ends when it's done. Why is this useful? Because it allows for uniformity. So I tell the Docker or the developers of this source to, hey, just go run Docker pull and then pass your source code through this, and you'll get out the same results that you will get when your pipeline, using my same image, builds. So it makes it very easy to distribute. As I mentioned later on, I just publish to our internal Docker registry, and then they Docker pull and get what they need. It also makes it plug and play with the CI pipeline, as I mentioned. Every modern continuous integration stack will easily let you pick up an image and run on top of it. So this project is using GitLab, but internally we're all kind of moving to GitHub, an enterprise version of that. And both, as well as Jenkins, easily allow you to interact with and use Docker. And then, yeah, there's 0 environment setup. If you have Docker installed, I guess that would be the setup. Otherwise, once you've got it, you don't need to worry about incompatibilities, about making sure that your Java command or class path is just right, or that you have all the dependencies pulled down for a given node package or Python, whatever. So yeah, in this particular instance, we have documentation embedded in the source that's either written in C or in Sass, the programming language. And these projects are versioned in GitLab. These developers have been delivering documentation written, tagged up as Doxygen. You may be familiar with that if you've used C or probably not Sass, but in any case, it's all just comments directly in their source code. They can run a step in their builds that builds deliverables that are then delivered to their users. Generally packaged with the deliverable, the actual packages we're sending out to customers. But now there's more emphasis on making sure that all of our documentation lives in Help Center, our web application, our documentation.sass.com. And so they want to both still be able to deliver their content in the deliverables to customers, because some customers are black sites. They want to be able to, or they would like to be able to edit that content for their specific needs, but then also they would like the content delivered to our forward-facing customer site. We could easily do that if we just lifted and shifted to, we have our own proprietary DTD and publishing system called XIS, XML Information System. It's very original. But as I said, they would like to continue to edit their content in their source. So what I did in this instance was to containerize it. We've got a brief overview. They have their source code, and now with this Doxygen transform image, they can drop that into their CI/CD pipeline. It will generate first, their Doxygen transform will generate Doxygen XML, and then my new image is dropped into another step after that, and they'll take all the XML files and they will drop that into CVS, where all of our documentation still lives. Long story, it's going to GitHub, but it's a painful process to move from one to the other. They're very different. And then once it is actually in our traditional documentation project repository, it's very easy to pipe straight to Help Center and then go to pre-publish, so on and so forth. So in the image, and why this is useful, I can package up everything. So we have our own array of Java extensions and a whole build environment. But in this case, all I really need is the ability to build our custom EIDs, which is a compressed UUID. And we package that in a jar. It handles, it also contains a Saxon processor and an initializer, so we can mount our extension. They can then, when my transformations run, it will take Doxygen XML, which doesn't have great identity on individual elements, and then I can use my UUID to generate stable links and all that good jazz and stuff valid against our DTD. It's built on top of a base image that is internally managed, which is nice because then I don't have to be too concerned about security vulnerabilities, that sort of thing. And then the entry point shell script is actually what the user sort of interacts with by running Docker run. Docker run will run that shell script, which actually just kind of does the jar and all that good jazz. So let's see it in action. Here we have the Docker file. This is a bit of subterfuge. We have our own internal build tooling that's based on Gradle. So I actually don't write Docker files anymore. I write something in YAML, delightfully, that will eventually become a Docker file. But in any case, this represents what comes out of it. And this is our internal universal base image. But if you were interested in doing something like this for yourself, there's myriad ways you could get access to like the Java environment. One that's very good is Amazon manages one, and they promise that it will always be up to date security-wise, and that's based on Linux Alpine, so it's nice and secure. If you have another language of choice, if you'd rather write in Go or Python or whatever, there's a base image out there. It's very easy to find. You can go to registry.docker.com and find it. In any case, as I said, these Docker files are basically just recipes. So I say, hey, copy over the results of my build, which would land in this build folder, into the Docker container, and then the second part is where I would like it mounted inside my container. The same thing, take my XSL, plop it over there, and then I'm telling Docker, hey, expect a couple environment variables, and then I'm declaring, or create a couple of environment variables, and these are the just standards which I expect the user will override eventually. And then I've got another one for the class path, so that way everything knows where, Java knows where to find things. So yeah. Here we have the entry point. As I said, there's actually a shell script now, but this is an earlier version. But the shell script more or less does this. It runs my particular class. And then I've also told users when they're doing this to mount an input and output directory in Docker when they're running it. And then my script expects to find the input and output files they specify. So here is actually how they would run it. And it's, first they would actually, let's see, pull. So if you don't have it, you would pull from the registry. This is our internal registry.unix.sas. So this is basically our internal instance of a Docker registry because security. And once they've pulled it, it's very simple to run. Like I said, they know that they need to, right here, this is a volume mount. So I'm saying, hey, go and look in this input folder over here. And that's where you'll find your input. You mount the input, so on and so forth. The same with the output, which I'd like in this folder. They run it. I compiled this in a different platform. It doesn't matter. It still works. So it runs, boom. It's very easy for them to use, but more importantly, it's easy for users to use, or for their engineering group to use when they create their CI pipeline. So I'm just showing you here, this is jobs run whenever they run a commit. So when the developers in this risk group write new code, it runs myriad steps, and one of which is docgen, and that's when my container runs after the docgen XML is built, as well as the HTML and all that good jazz. It'll generate my XIS XML. Was there anything else I wanted to show? Yeah, so you get to go from the documentation in their raw source over here. This is a SAS macro program. And yeah, so it goes from here down here. Generates this docgen XML, which then generates this lovely document DTD. We name things very originally. XML, and then, yeah, eventually, this is the same content. And that's all nice. It's very easy to, transform things. We do that all the time. But what's cool is that it's all done in a way that is easily usable in multiple places. Let's get back to this. So this is their, I don't want that. How do I get back to just, okay. There we go. So this is a representation of the CI/CD pipeline. So they, as I described, they'll revise their source, they'll push it, and as part of their pipeline build, it recognizes the change set and recognizes all the new files that have changed. It'll run through the Stoxygen transform and generate a bunch of XIS XML files, which then their pipeline will drop into CVS. They can preview it, and once they like that, then they can commit the CVS preview or the CVS content, and it will automatically build and be delivered to our site. So a couple considerations if you are pursuing using Docker, which this, again, may be review for some, but very important for us is to always use the lightest base image you can. We're using Alpine and then as little on top of it as possible. And in my case, I'm putting nothing on top of it because I'm using a base image that someone else manages. And that would work well for you as well if you find like this Amazon one that they promise to always keep up to date, dealing with CVEs and whatnot. If you need much more, you might want to think about what you're doing and think about ways to strip your program down. Generally speaking, you shouldn't leave your user as root, but there are caveats. I still run as root because I discovered incompatibilities with Windows and Linux. So if you write to subdirectories in a mounted folder in Linux, that's fine. But if you do it in Windows, there are permissions problems and it won't work. So I now run in root knowing that it doesn't matter a great deal since this is not a long running process. So hopefully no one will exploit that. Secrets management can be cumbersome. So it's very easy in the cloud or in a CI pipeline. You store the secret and that's not a problem. It's not a problem for me now, but so we're using Saxon HE. We do have an enterprise license, but I was able to avoid it with the way, we were just not using anything that we need professional or anything like that. However, if we did, it's easy to store that secret in the cloud, but it's much more convoluted to distribute sensitive information to end users. So you could theoretically put that in your image, but then they could probably get it out. That's something it's just a consideration. So some future work. I created this project pretty quickly at work. It works, it's great, but I think upon reflection, it would make more sense for me to make a base image that just contains the controller and not just this, but other, I'm running late. Sorry, I know, I took too long. In any case, it would be better to build a base image with just the controller and then to add XML on top, so that way it would be reusable for different purposes. And to that end, I've mentioned to Norm, I think that eventually it would be nice if there were a Saxon Docker image. That exists for Antenna House's CLI, so a way for anyone out there to pick up Saxon without needing to create your own image with the jar in place or Saxon C in place, so that you could do what I did more quickly. There are some images, but they're just community run, and yeah. I think that's about it. Does anyone have any quick questions?
Thank you very much, Ed. So we have time for one question. There is a question over there. Anyway, you will have plenty of time during the lunch.
Hello. At Pantapix, we are also trying to use fast the same process to be able to use some pipeline transformation, and maybe one of the problems we are facing is, for example, to be able to pass the output of one transformation to the other one. And doing it with the volume, it can be done if you are using you have all the steps in one. But if you are splitting to have, to have more control, how can you do it?
I think it depends on the CI platform that you're using. So in GitHub, you could use, you could pass from one step or one job to another, but you need to specifically, you need to look it up more or less. I can't remember off the top of my head, but we do that in our new build pipeline for our GitHub-based projects.
Okay, thank you very much. We are running a little bit out of time, so I would suggest postponing questions. For lunch, you can catch at here. Thank you very much again.